Question 1.1. How many correct experiments do we need to disprove a theory? How many do we need to prove a theory? Explain. The number of correct experiments we need to disprove a theory is 1. A single counterexample is enough to disprove a theory.
Question 1.2. A guidebook describes the rate of climb of a mountain trail as 120 meters per kilometer. How can you express this as a number with no units? As we know, the given rate is 120 meters per kilometer. To do required, we use the conversion factor, which is given as 1 kilometer is equal to 1000 meters. Therefore, when we apply conversion factor into our case, we get rate is equal to 120 meters per kilometer, multiplied to 1 kilometer over 1000 meters, then cancel out the meter and the kilometers. And now we will have rate is equal to 120 over 1000. As you can see, it is now unitless, and as you divide it, it will be equal to 0.12.
Question 1.3. Suppose you are asked to compute a tangent of 5 meters. Is this possible? Why or why not? The answer is no, it is not possible because the units for the tangent function are being expressed incorrectly. Physical units, like meters, do not belong inside the tangent function, it is purely a unitless computation. Question 1.4. A highway contractor stated that in building a bridge deck, he poured 250 yards of concrete. What do you think he meant? The contractor is talking about the volume of the concrete, so he meant he poured 250 cubic yards of concrete. Volume is equal to 250 yard cube. But he did not mention the cubic word because it is the common way to talk to the worker in this field. It is like when I say, I have a 100 meters house, I really mean the area of the house 100 meters square, but I did not mention the square because we never do that in trade, it is not common in selling or buying a house. Question 1.5. What is your height in centimeters? What is your weight in newtons? Here is the process we will use to convert imperial units to metric. Let x equal to your height. So we have x inches times 2.54 centimeters over 1 inches and cancel out the inches and it will be equal to 2.54x centimeters. So this will be your height in centimeters. And the next one, we have x pounds multiplied to 4.448 Newton over 1 pound, and here let's cancel out the pounds so that it will be equal to 4.448x newtons. So this will be your weight in newtons. Question 1.6. The U.S. National Institute of Standards and Technology, or NIST, maintains several accurate copies of the international standard kilogram. Even after careful cleaning, these national standard kilograms are gaining mass at an average rate of about 1 microgram per year when compared every 10 years or so to the standard international kilogram. Does this apparent change have any importance? Explain. Yes, the change in mass has a significant importance because, so far, we do not have a standard of mass that is based on a fundamental natural constant, like the number of cycles per second of radiation required for a cesium-133 atom to reverse its outermost electron spin. This may change in the future, as our descendants could possibly find a way to measure mass without using a variable chunk of metal. Question 1.7. What physical phenomena, other than a pendulum or cesium clock, could you use to define a time standard? The pulsar stars can be used to define a time standard. The pulsar star is a kind of star that emits a heavy beam of electromagnetic radiation in constant time intervals. This time interval differs from one pulsar star to another, so we can use a definite pulsar star to define a time standard. Question 1.8. Describe how you could measure the thickness of a sheet of paper with an ordinary ruler. Well, it wouldn't be entirely accurate, we could get an estimate of a sheet's thickness by stacking enough pages until we reach a single inch or centimeter, then divide the unit by the number of pages stacked to that height. Question 1.9. The quantity pi is equal to 3.14159 is a number with no dimensions, since it is a ratio of two lengths. Describe 2 or 3 other geometrical or physical quantities that are dimensionless. Several examples include the mathematical constant E, encountered frequently in calculus. E is equal to 2.71, and also the geometrical angles like 15 degree, for example, are also dimensionless. Question 1.10. What are the units of volume? Suppose another student tells you that a cylinder of radius r and height h has volume given by pi r cube h. Explain why this cannot be right. The units for volume are length cube. The student is wrong because pi r cube h is not the volume of a cylinder, it is pi r squared h. The student is incorrect because his answer has 4 spatial dimensions and not 3 like volume. Question 1.11. 3 archers each fire 4 arrows at a target. Joe's 4 arrows hit at points 10 centimeters above, 10 centimeters below, 10 centimeters to the left, and 10 centimeters to the right of the center of the target. All 4 of Mo's arrows hit within 1 centimeter of a point 20 centimeters from the center, and Flo's 4 arrows all hit within 1 centimeter of the center. The contest judge says that one of the archers is precise but not accurate, another archer is accurate but not precise, and the third archer is both accurate and precise. Which description goes with which archer? Explain your reasoning. Joe is neither accurate nor precise, he didn't come close to hitting the target center, and his shots are not clustered neatly. Mo is precise, but not accurate, he didn't hit the target, but he grouped his shots in a very tight spacing. Flo is both accurate and precise, she nailed the center of the target with a very tight spacing of her shots. Question 1.13, can you find two vectors with different lengths that have a vector sum of 0? What length restrictions are required for 3 vectors to have a vector sum of 0? Explain your reasoning. A 0 vector has no length. Its head is at the same point as its tail. Vector sums are geometrically performed by placing the tail of the next vector onto the head of the previous one. The resultant vector as tall has the tail of the first vector and the head of the last vector. Two vectors adding to 0 means that the second vector should start at the head of the first, point in the opposite direction, and end at the tail of the first vector. This means that they must have the same length and opposite direction as shown in figure 1, so the answer of the first question is no. 3-vector case. From the geometric procedure, it should be obvious that the 3 vectors must form a triangle, or maybe they lay on parallel lines, with the shorter 2 pointing to the opposite direction of the longest, as shown in figure 2. Accordingly, their lengths A, B, C, in any order, must satisfy the modified triangle inequality. A plus B is greater than or equal to C, where the equality represents the collinear case, while the inequality is for the triangle. Question 1.14, one sometimes speaks of the direction of time evolving from past to future. Does this mean that time is a vector quantity? Explain your reasoning. We only perceive the elapse of time in one direction. It always increases, turning back time happens only in song. Elapsed time is fully represented by a positive number, in units of seconds, hours, etc. Specifying the direction is not necessary, we know it will always go forward. Therefore, time is a scalar quantity, not a vector. Question 1.15, air traffic controllers give instructions to airline pilots telling them in which direction they are to fly. These instructions are called vectors. If these are the only instructions given, is the name vector used correctly? Why or why not? The air controllers issue direction. But a vector always includes the second component, magnitude. Since the magnitude is not instructed, air traffic controllers should not be labeled as vectors. Question 1.16. Can you find a vector quantity that has a magnitude of 0, but components that are different from 0? Explain. Can the magnitude of a vector be less than the magnitude of any of its components? Explain. If a sub x and a sub y are components of vector A, then the magnitude of A is given by a equal to square root of a sub x squared plus a sub y squared. The only way this can be 0 is when the components a sub x and a sub y are both 0. So, the answer to the first question is no. From the same relation, we conclude that the magnitude A is at least equal to a sub x or a sub y when the other is 0, and it cannot be less, which answers the second question. Questions 1.17, A. Does it make sense to say that a vector is negative? Why? B. Does it make sense to say that one vector is the negative of another? Why? Does your answer here contradict what you said in part A, a number can be negative? A vector cannot. A given vector has a definite magnitude and direction. What could happen is that the direction is defined to be opposite to a predetermined direction, but that would be only in comparison to another defined vector. A vector being negative, without a reference to another vector, does not make sense. B. A vector being the negative of another is a valid statement. Take any vector A, then define the vector B with its tail at the head of vector A and its head at the tail of vector A, so it has the same magnitude of A, but the opposite direction. Their sum is the 0 vector. A plus B is equal to 0, so that it makes sense to write A equal to negative B. This does not contradict what we concluded in part A, as, in this case, we are comparing two vectors. The vector in part A has no reference to another vector. Questions 1.18. If the vector C is the vector sum of vector A and vector C is equal to vector A plus vector B, what must be true about the directions and magnitudes of vector A and B? If C is equal to A plus B, what must be true about the directions and magnitudes of vector A and B if C is equal to 0? Since C equals A plus B, then A and B must be in the same direction and the angle between them is 0, or in other words, they must be parallel. In this case C equals A plus B, but if their phase shift between them, the magnitude C is not equal to A plus B. If C is equal to A plus B is equal to 0, then A equals negative B, so A and B must be equal in magnitude but opposite in direction.